All right, welcome, and thank you for showing up in spite of the rain to this meetup. We are talking about data integration today, and we have a pretty packed agenda. First up, we'll talk very briefly about Apache Goblin, what's going on with it, the latest news. And then we have Prezi in the house. They're going to be talking about how they gobble data at scale. And then we have Machine Zone, who'll be talking about how they are doing their data ingestion and data management piece. And finally, we have LinkedIn talking about how we're doing data democracy while preserving data privacy. And then we can continue chatting and finishing up however much booze is left. But to kick things off, Abhishek, he's the Apache PPMC for Goblin, and he'll give a quick intro to Goblin and what's going on.
Thank you. Welcome, everyone. So I'm Abhishek, and I'm Apache PPMC for Goblin and Committer, as well as part of the Goblin team at LinkedIn. So I'll briefly talk about what's new and great at in the Goblin world. So what is Goblin? So Goblin is a distributed data integration framework that simplifies different data integration things, such as ingestion, replication, organization for both streaming and batch data ecosystems. We say integration, not just ingestion, because Goblin is really a framework that has evolved from being just focused on ingestion and replication to being a full suite of things that does lots of data integration stuff, including data lifecycle management and other things. In terms of our vision, we want data to appear anywhere in any form that you want. And we take that vision and we try to work out everything that we built around that. And similarly, our mission is also to build highly scalable platform to achieve our mission and simplify the data integration management and data management for small and large data ecosystems. So I'll talk about a few great things that happened since our last meetup. So first being Apache incubation. So we incubated an Apache in February last year when we were accepted. Since then, we worked with internal processes and legal teams to do the coordination and start the Apache infrastructure setup, which happened around in November of last year. So now we have a new website. We have new mailing lists to communicate. We have a new way to track issues. We have a new wiki. We have open sourced our design documents are open sourcing most of them. We have a new way to talk real time over Gitter. We have a new way to suggest major initiatives within Goblin in open source world and let external folks drive them. So that's the Goblin improvement proposals section. You can find that on Wiki. We also have our new first external committer, which is Joel. Many of you know him with the name of Kadan. And our first Apache release is in progress. We had a release candidate, but we need some more work, so we are coming up with the next release candidate soon. Another big update that now we support multiple execution modes. Many of you know Goblin from a while back when it used to just run as an MR application in MR mode. Now it can actually run in multiple modes. So you can run it as in a standalone JVM or in embedded mode in your application. Or you can run in MapReduce mode, like it traditionally had the strong foothold in. Or you can run as in cluster mode on Yarn or in Mesos is in progress. Someone in the community is actually driving that. Or you can run again as an Elastic cluster on AWS, and Azure mode is also in progress. And someone in community again is driving that effort as well. Another big update, we have also come up with something called as Goblin as a Service, which is our attempt at building platform as a service around Goblin. What it does is that given Goblin's evolution into solving multiple data integration use cases, We have multiple deployments of Goblin within LinkedIn itself, but provisioning and setting up jobs across all of those deployments becomes pretty hard. So Goblin Service kind of sits in front of all of those deployments and makes your job much more easier to provision jobs across all of those deployments. So like you can just do a self-serve and set up job through Goblin Service on the first instance, which is like Goblin running on AWS, reading somewhere from somewhere and writing out to HDFS. Then another job that would simply do a format conversion, another job that will replicate data. It would help you better make use of your resources, help you get a better global state of things, or just simply change your deployments behind the scenes without affecting the users. Then another major thing that we have worked on recently is implementing global throttling. What it does is it provides a centralized place using which you can bound the total QPS of all the applications that you have in your ecosystem, so that different applications running within your infrastructure can just talk to that throttling service, and that throttling service can control the amount of QPS each application is using to talk to one of the resource that you want. And this is also pretty generic. You don't have to really use it just with Kotlin. You can integrate it with any kind of application that you have and make use of it. So, so like in this diagram that we have one Kotlin instance using it, and then there are two other generic apps which are just talking to the same throttling service. In terms of other announcements, we had many new things happen and lots of work done around stability of different components. But one of the major things that we did was around stabilizing and improving the Kotlin cluster. We spent quite a bit of time to make sure that it works nicely at greater scale. And then we have a better stream processing support. It's getting slowly and steadily on par with all the offline processing that we already do pretty nicely. We have new sources for Google Analytics, Google Drive, Google Webmaster, partition app profiles, new extractors for Postgres, new converters like JSON to Parquet and so on, new writers for Parquet, Salesforce, and also another interesting contribution from externally in the community has been great support for eventually consistent file systems like S3 and others. So you can get involved in the community by just sending out an email on the mailing list or just pinging us on the Gitter, and just talk to us if you have any ideas or if you want to contribute in any way. Thank you.
If you have any questions, either raise your hand and I'll pass a mic around, or we could kind of do it after the talks as well. Any questions? All right. So next up is Prezi. Tomasz is going to talk about their data ecosystem. So Tomasz actually flew here all the way from Budapest just to give this talk. So he's a really invested Goblin user. And he works at Prezi, which I don't know how many of you are familiar with. Prezi is one of these really cool presentation-making companies. I think I'll let him give the...
Yeah, thank you. So hi, everyone. I'm Tomasz, and actually I'm leading the data platform team at Prezi. And I will guide you through our journey about how we ingest or gather data at Prezi. But first of all, I'm not sure how many of you are familiar with Prezi. So some of you, cool. But for those who don't know, basically it's a presentation tool what I'm using. But let me give you a talk a few words about Prezi. So, Prezi was founded in 2009. We started at Budapest, Hungary. And later on, we opened an office here in San Francisco, and basically that's why I'm here. And of course, because I'm giving this presentation about Goblin. And last year, we acquired a data visualization company called Infogram. So since that, we have office in Riga as well. A few numbers about us. We have more than 85 million registered users at Prezi, and we have more than 325 million Prezis created so far. And a few words about my team. It's a relatively small team. We are a team of 5. And we're trying to, and basically we are responsible for creating core data sets till operating and running the data warehouse, the Hadoop cluster, and building all the tooling, what's needed, people who are interested in data. But how we started and what's data in our case? Who do you think, who think that data ingestion is easy? No hands up? Okay, I will show you, it's easy. So this is how data ingestion pipeline look like initially. So at Prezi, you can use your mobile or desktop viewing or editing Prezi, actually editing only on your desktop computer. And you can also go to the website, and whatever you are doing there, it will generate some kind of event. We are collecting those events because we are interested in what our users are doing and making the product, so tailoring a product for our users' need. And of course, and when I'm talking about events, it's usually, in our case, or data, it's more than 90% it's application logs or application events. And of course, we have services as well, which produces like microservices, backend services, which also generates log lines as events, and we want to collect them as well for processing. For that, we use Scribe. I'm not sure how many of you are familiar with Scribe. It was open sourced by Facebook, and 4 or 5 years ago, they abandoned the open source version. We use that because that time it seemed to working fine. Basically what it does, what we did, we just moved logs or events into one central machine. And from that one central machine, we wanted to move the data in Amazon S3. We are fully on Amazon, so what I'm be talking about, it's more like the AWS tools. Why we moved to S3? Because we are using EMR, which is Amazon Managed Hadoop, and if your data in an S3, you can crunch that. So when nobody put their hand up, when I ask data ingestion is easy, I will show you. So there we had a script. It was basically logupload.sh. It was a few hundred lines, and that's it. So we just, every hour, logs ended up here, and every hour we just compressed those logs, and based on category, we copied onto S3 under one directory, and the file was named like, I don't know, log, date, and hour, and that's it. We just copied there. And we just crunched with Amazon EMR. And why? We stored in S3 and not like HDFS, which was, if you are not familiar with Amazon EMR, there you start a new cluster, and you should only store temporary data on HDFS, because anytime you want to upgrade your cluster, that will mean you have to tear down your cluster and start a new one. If you have but it can use S3 as a file system, so if you have data there, you can crunch your data. And another benefit of that, if you want to run a huge backfill, you can just parallel start up a new EMR cluster, and that will be able to access S3 as well. And we created nice charts, so we are done. As you can see, don't worry, the cron job is running fine. And actually not. So we had a few problems with that. First of all, it didn't scale. We had issue like that. Shipping 1 hour of logs lasted more than 1 hour, and we couldn't do much because we had one machine with a bash script there. It was hard to detect late logs because whatever logs came in an hour, we shipped in with that hour. So if some application server failed to send logs from yesterday, but send it today, it ended up with the today's logs. And you can imagine if you run to backfill or if you wanted to somehow figure out what are the late logs, we had to do a lot of manual process to do. And because we had this nice idea to put everything into one directory, which was fine for the first few days. But after 5 years, when you have 365 times 24 times the year, so you end up a lots of files. So even if you just try to list that directory, it takes for a significant amount of time. If you want to work with that, so the first half an hour or 45 minutes will be just S3 calls to Amazon just to get the files. Okay, don't worry, we try it again. So 1.5 years ago, Prezi did, at Prezi, earlier we used Flash, we moved to HTML5, so we thought that, okay, this is the right time to re-implement our data pipeline with the data pipeline v2.0. Here the idea was that, okay, the beginning is fine, so we still need the events. Then we thought, okay, the easiest way to solve the scaling issue, if you just add the Kafka, that's cool because that scales. We moved the data in with 5-bit, and the rest still remained. Here the question was, what to use to ship from Kafka to S3? And because we burnt ourselves previously, we had clear expectations. First, we wanted to ship the logs from Kafka to S3. And we wanted to partition the logs. So making sure we won't end up with one directory, all of the files. We wanted to make sure, based on the logs, we get the date, and we basically create partitions, which is good for Hive as well. And if you want to ship logs from Kafka to anywhere, most of these tools, how this works, of course, as many partitions do you have, that many files will be there. So if you have 10 partitions and you ship logs twice per hour, you will end up with 20 files. We didn't really wanted that. We wanted to do compaction. And we wanted some kind of solution to the late logs. So we were looking at different tools. Shipping to Kafka, it's easy. There are a bunch of open source tools that can do that. Partitioning logs, that's also easy. There are a bunch of tools as well. But the last two was surprisingly hard. We couldn't find a tool. So I really felt like that. I want to cook. I need chicken breast, but the only thing what I can buy in the store is a real chicken. What? So it seems like everybody, at what we saw in different companies, people are implementing from scratch all this compaction and late log handling, so every company has some kind of different solution for that. And that's where we met with Goblin, and it was awesome that they had all this functionality. So it knew the log compaction and the late log handlings. So we are done. We love Goblin. But every relationship has ups and downs, and we had as well. First, the biggest problem was that we are with S3 on the US East 1 region, which is eventually consistent. Which means if you write the data to S3, that doesn't mean you can immediately read it back. So what we did in this case. So for Goblin, we implemented some kind of retry mechanism, which means first write the data, and Goblin won't fail immediately. If the data is not there, it retries a few times. And if the data will appear, then nothing will break. We started to use a MySQL state store because we couldn't store the state store on HDFS, because if you restart or start a new EMR cluster, we would lose that. If we would store that on S3, that's eventually consistent, so we can't really trust in that. So, and another recommendation from us, that wherever possible, use HDFS for temporary data, because HDFS is not effective with consistent, with this eventual consistency. Actually, to be honest, on Amazon, you have a consistent view which can do something with this eventual consistency, which is fine until you are only touching data on S3 through EMR with EMR-FS. But in our case, that was not true, of course. But the good news is that it's already in Goblin. So for you, you can use as of today and before. So it's there. We contributed back. And another issue was that at that time we used JSON data, and we needed JSON compaction. And Goblin really supports Avro, but JSON, there is some kind of limited support. So we needed to implement some kind of JSON compaction and partitioning based on a JSON timestamp. Actually, it's pending. So we have this implementation. You will see why we not contributed back yet. But if anybody is interested, it's on our fork, and we really plan to contribute it back if the community see the value in it. And steep learning curve. So I think I have to be honest. Goblin has a steep learning curve. So if you start with Goblin, sometimes you have to dig deep in the source. Actually, it's a very powerful tool. It's lots of possibility in it, but sometimes really you have to dig deep. And where we are now and what we are working and what's the future for us. Basically, with the logs that we had so far and with this JSON data, engineers could easily change an event or introduce a new event, because the idea was there, log everything. And we ended up in a jungle, which we called logs jungle. And now we're trying to get out of a jungle, because we just realized that data quality is most important. So we are just redesigning again our data ingestion pipeline. Making sure developers, engineers can break our data pipelines. What we are working currently is basically moving to Avro and with the Confluent Schema Registry. And what was really great experience with Goblin, it worked like a charm, really. With minimal effort, a few days we could do. Make it work. It has the automatic hype registration, also worked like charm. So we really love that. And so please guys, be prepared. There is some very terrifying moment here where we would like to use as well Goblin. Are you ready for that? GDPR. So yeah. We have a long work ahead with GDPR, and Goblin is really a key component in our GDPR work. So this is just the briefly what was our journey with the data ingestion. And thank you, guys.
Any quick questions?
Yep.
All right. I think we have more than one mic. So why don't you?
Okay. Cool.
Thanks for the talk. Quick question. What is a file beat?
It's an Elastic project. So to be honest, we always try to use open source technologies, and we are looking for such an open source project where the community is active and helpful, and they open for contributions. And Elastic FileBeat basically a very small sender which can basically tail a file, and then it can send to various destinations. So in our case, we just basically, first we buffer log. So we have a logger service which gets messages. We write it to a file for a buffer, and from that file, Elastic FileBeat just sent to Kafka the messages. So basically that was a buffer. So if
Any other questions?
All right, thanks for the talk again. Can you talk a little bit about how Goblin is helping you with GDPR?
Yeah. Actually, one place where I see really plays, it's the this data retention. We don't really doing pretty good work in that, but in the future we will. But to be honest, this GDPR work is still ahead, so we are still working out what we really would like to do. But if you check out Goblin, there is a lots of great things around this, and what we will need for GDPR.
Yeah, I think the LinkedIn talk will have some details on that. Any other questions? All right, let's move on to Machine Zone then. Thanks so much. That was definitely one of the funniest presentations I've seen about Goblin so far, so thank you so much. I will never look at chicken breast the same way again.
All right.
All right, great, thank you.
Can you? Okay. I don't think I'll be quite as funny. So, all right. So yeah, I'm Michael Drabelbis. I work at Machine Zone. I do data ingestion. Yeah, basically, I'm going to talk about what we use Goblin for and kind of the road to choosing it, and some of the customizations and stuff that we've done. It. Little marketing information here. Machine Zone is a mobile gaming company. We have kind of built a marketing, what we call performance marketing platform around leveraging a lot of different ad networks to buy a bunch of ads and get ROI on top of it. We have what we call the Cognate division, which is the business unit that handles all of the marketing data and handles all of the internal game marketing data as well as for our external clients, because we turn this into a product. So kind of little overview of what we're going to talk about. Kind of the requirements that we had and some of the problems we were encountering, how and why we chose Goblin, then through some of the customizations and how we deploy Goblin and how we use it, and then we'll go with some questions at the end if there's any time. So yeah, so for kind of an initial thing, we ingest data from over 300 different ad networks. We work with a lot of different companies, and they have a lot of different schemas and a lot of different, I don't know, the ad performance data, it all looks very similar, but all these companies have different representations of basically the same data. So we have to take it all in, do some normalization on it, and put it into a reporting mechanism. So we needed to support ingesting data from REST API and email through kind of Gmail ingestion, S3, and we also do streaming ingestion for clickstream data, mostly for cold storage for events from clickstream and also post-install events. And basically, yeah, so we need to take all this data from all these different sources, normalize it, put it into kind of a reporting schema that made sense. We needed to support partial data sets, so we didn't always get a full refresh for a particular partition. It could be partial, so we needed to support that. I'll talk a little bit about that later. And we needed something that scaled horizontally because as the business grew, we needed to handle that. So why did we choose Goblin? So talk a little bit about kind of history there. We were a little bit familiar with Kamu, which is kind of the predecessor to Goblin. Used Kafka to HDFS, pretty stable framework for doing so. I'd used it before, so pretty familiar with that. Had some stream and batch both as a requirement there, so that was useful. For us, it was a minimal learning curve. I know you said there was a steep one, but since we had used Kamu before, it wasn't too difficult to get put together for us, and it was configuration driven, so we didn't have to spend too much engineering resource to build a lot of things. Some of the bad stuff, I don't know, bad is not really the word I should use there, but there's no higher order API, so we use it primarily for data ingestion, just pulling in data, taking it from one source and writing it to another. If you want to do like more complex transformations or more complex applications, you might want to use something like Flink, Beam, or Spark. They have a higher order API for interacting with data sets more so than Goblin does. There wasn't really much community support when we started working with Goblin, which was back in April of 2016, and there was no nice GUI to like see where jobs were going and that sort of stuff. So that was some of the negative points with Goblin, but it fit the bill, so we ended up going forward with it. Talk a little bit about the kind of initial thing. I don't know how much people know about how it works, but I'll talk a little bit about this and then go like what customizations we had on top of that. So everything like comes from the state. The state is like all the properties that a job runs with. You use the state to generate all the work units that are sent to for task execution, and basically the source takes the state to generate work units. Those work units are then run on, if you're using MapReduce, a particular map task. That map task creates an extractor which runs the extraction to pull the data from the source, generates an iterator which is then passed to the converters, which there can be one or many converters, and then that is sent to the quality checker, which does some checks around there's a couple different types of quality checking. You can do row type quality checking or task level quality checking. We have a couple of custom ones that we use. And then if it passes the quality checks, it goes to the partitioner writer, which will split the data up and write it to the destination. It's usually a temporary location. And then the publisher will take that temporary location, make it final. In HDFS, that's the final thing. So that's normally what we kind of publish data to. So we started using Goblin at 0.6 a long time ago, year and a half. And took us only about 3 months to go to production. There's only 3 people working on it. So it was pretty easy for us to take like the initial thing and kind of work it to a productive environment. We didn't really change any of the core code. We just pulled in the libraries and the runtime environment and added our own customizations on top. We've been upgrading it all the way to 0.9. We stopped at that point because 0.9 was working pretty well for us, so we might upgrade later, but that's what we're currently working with. We replaced an existing like homegrown ingestion framework. It wasn't very good. We had like this ingestion for Facebook that never really worked. Got it to under an hour, which was pretty good. And we have our own DSP we were ingesting data from. Used to take 5 hours, got it down to 20 minutes. This is just because the HDFS splitting of files was pretty good, and we didn't have that in use before. So how would we deploy it? Goblin, they talked about, they have kind of standalone mode and MapReduce. We use both like local mode for developing new features and integrations, and then we publish to our Hadoop cluster to do the MapReduce jobs. Local mode's pretty nice for the devs to do the new testing and new integrations. We use Jenkins to deploy everything to like the runtime jars to the Hadoop cluster, and then we use Azkaban for doing all of the job scheduling. We manage about 225 different ingestion jobs with Goblin, and we separate the jars with the job files. You can package them all in one for Azkaban, but that's an Azkaban talk. Basically, like we separate them so that we can deploy them independently, because the job files change more often than the application jar does. So yeah, some of the customizations we made. Since we started before, there was a lot of this support. Some of these things exist now in the core libraries that didn't exist when we were there. S3 file support, email file support. We were doing CSV extraction, so we needed header validation on the email files because people were sending us files with columns in different orders, so we had to implement that. The REST API extractor for Goblin is pretty good if you're just doing a single pull of data from an thing. We didn't have anything for handling async polling or pagination, so if you had a job that took a long time and then you had to pull an endpoint, we had to implement that ourselves. So that's something we probably could contribute back to the community, I guess. Yeah, one of the biggest changes or features that we implemented was a rule-based converter. It basically takes an input record and any number of like custom rules. They're defined by a rule set. Those rules are then read in, parsed, and then applied on the input record to populate the output record. Some of those like examples like numeric cast or timestamp, date, math, substring, these are all things that are required like when you're dealing with so many different types of data sources, normalizing them required us to have a pretty flexible, so that's why we implemented this. For quality checking, we implemented a required fields policy, which basically checks to make sure that there are certain fields in the destination records. It's a row-level policy. So yeah, that's some other things we did. For the partitioning, Goblin has a time-based partitioner, which had the ability to do schema columns before the time partition. We wanted to have both before and after time partitioning, so we had to implement a custom one to do that. There was no support for ORC or Parquet when we started, so we wrote our own. And we used the Parquet one the most. It has the most support in like for our downstream applications, so we didn't end up using ORC, but yeah, that's kind of, I don't know how well people can read this, but basically this is just a kind of high-level overview of all the different data sources that we use. All of the entire box represents Goblin. This reads the data, goes through the rules engine converter, which loads the transformation rules. We have one per data source per network integration. So for like example, Facebook spend has its own transformation rules. Facebook campaign data has its own transformation rules. These are all written to what we call the unmerged data set. So compaction was a big problem for us because we were using so many different types of data sources, and I'll talk a little bit about that in this slide. So some of the learnings we had, job properties, templating was not initially implemented. It came in 0.7, I believe. So that helped us a lot. Once we had so many job files that templates really helped us manage the properties well. One thing we really didn't like about Goblin was that when you initially start a job on like the Hadoop cluster, on the driver, it materializes all of the work unit states in memory. And we had one job that kept blowing out the memory. That was a big problem for us. So we had to figure out like some different ways to chunk it out. We enabled like metrics and monitoring in Goblin, but it was just way too much noise, not really anything useful for us, so we had to disable that. And then a note about compaction. It works great if you're using Hive tables with single primary keys, or if you're JSON key ordering matters, if you're writing out to JSON. So we had to write our own custom compaction application. This is because we had a single like add performance table that was pulling in with multiple different primary keys from all the different data sources. So we had to write an application to basically support partial merges for that. These are some stats around what we're using currently with Goblin. We ingest about 125 million records per day for like just spend data. We manage over 500,000 ad campaigns, 5 million ad groups, 20 million ads. Our biggest ad job runs, these are all batch. Streaming is a whole different set of numbers, but in the batch, 7 million records for ads is our biggest one. And currently we're running 250 active ad integrations. I know I said 300 before, but we have sort of a revolving door of ad networks because some are good, some are bad. We have to kind of cull the herd. And yeah, so that's basically like what we do with Goblin. Any questions?
You mentioned that there are no higher level APIs. So where did all the rules stuff, like, how did you manage? Did you write custom code for everything, or?
Yeah, so we wrote, basically there's like a converter interface. And so we wrote a custom converter that it basically reads a rule set based on the known like data type that it's working on, and parses that into basically a set of like functions that can be applied on the input record. And that's basically how it works.
Other questions?
Sorry, so I'm a bit rusty in this space, but I used to work for a company called SnapLogic, and some of what you said reminds me of stuff that SnapLogic does. Would you mind contrasting what you guys do with what SnapLogic does?
I'm not familiar exactly with SnapLogic, but if you're talking specifically about what we do with the performance data, is that what you're referring to?
Actually, I think that's a better question. Again, I'm the dumbest person here, so maybe you can remind me of what exactly the value proposition is from you guys?
Right. So when you spend money on ads, right, you can pull that information. Like, okay, I don't know how much time you have, but basically what we try to do is we spend money on advertising, and we gather a lot of data points about where that money is spent and how that money gets turned around and turns into installs, which then turn into, or clicks, which turn into installs, which turn into revenue generating, the funnel, that sort of stuff. All of that happens after the point of ingestion, and sort of the purpose of this talk is to talk about the ingestion part. So, yeah, sure.
All right, I had one question. You had something on your slide on emails.
Mm-hmm.
So are you actually ingesting emails and then processing them?
Yeah, so we have an email account that is specifically for network ingestion from external parties. We basically, like, this job runs, it scans the unread emails, downloads them, and then generates work units per email that then get processed as a file, simple file ingestion. We also had to implement gzip extraction. That wasn't something in Goblin. I think it is now, but yeah.
Could you please contribute that back? Just from a context perspective, there's a lot of data sharing that happens over email, specifically keys. Like if anyone has set up a data integration where you're encrypting data, and then you have to set up an out-of-band way of shipping keys, that typically goes over email. So it's actually pretty cool if you can use the same technology to ingest both encrypted data as well as keep your keys in sync using email. So that's like pretty cool thing that you guys have done. Next up is LinkedIn. I think Eric and Anthony are going to be talking about what they've been doing. Thanks, Michael.
Thanks, that's okay. Hey guys, I'm Eric. This is my colleague Anthony.
Hey guys.
We both work on the analytics platform team at LinkedIn, and we're going to talk about how we balance data democracy with data privacy. Our friend GDPR might show up in this talk as well. So I joined LinkedIn about a year ago, and I think one of the first things I learned when I joined the data org is that one of our goals was kind of enable data democracy. So our kind of primary customers are LinkedIn data scientists or analysts, and what they do is look at member data, provide insights from it, and kind of feed it back to the site. So for example, people you may know, jobs you might be interested in, that kind of thing. And if I have my data scientist hat on, I want a couple of things, right? I want to analyze as much data as possible because I want accurate models. I want to discover any new data that's around as fast as possible because I might want to suck in more things to again, build better models. And I also want to access data as fast as possible. I don't want to have to talk to a data engineer. I don't want to talk to some security person. I want to kind of quickly and easily get access to data when I want it. But you contrast that, as a LinkedIn member myself, I kind of want my personal data to be stored only where needed and not propagated across 27 different hard drives because the risk of a breach is much higher. I want my personal data to be deleted when I close my account or request deletion. And this is actually a kind of, the right to be forgotten is enshrined in the new GDPR regulations, and I think it's always been an EU kind of tenet. And I also want my personal data to be processed only if essential and only if I consent. So I don't necessarily want my data being sent around or processed for any random reason at all. So we have this kind of paradox, right? The scientists want more data, they want to discover everything out there, and they want very easy access to it. As a customer, I kind of want less data. I want to discover any governance for people using my data without my consent, and I also want to make sure it's restricted, again, for only business purposes. I'm happy with my data being used for some purposes, but not anything out there. So let's talk about how we deal with data at first. So a quick information about the LinkedIn data ecosystem. I think people may have seen some of these slides before, but we have a large number of Kafka topics and data, from generated from what people do on the site, generated from database change logs, things like that. This all gets ETL'd into Hadoop. And then we also pull information not only from Kafka, but a large variety of other data sources: Salesforce, random REST APIs, could be MySQL, could be Oracle, and things like that. And Goblin powers most of these arrows. That's actually why we built Goblin in the first place, to kind of standardize all these movements back and forth. So I talked before about the right to be forgotten or the right for erasure. I think this is, I don't know if this is a direct quote from GDPR, but one of the things we want to do is delete all my personal data without delay, or when I no longer consent for it to be used. Translated to the analytics platform team, that means we need to be able to delete some subset or all data associated with the user when they ask for it. And this could be in Hadoop, it could be in Kafka, it could be in Oracle. It's across the LinkedIn ecosystem, although we're going to be focusing mostly on Hadoop today. So why is that hard? So, one thing is it means that we have to understand all the data that's on Hadoop. There's kind of, as you saw before, we have data from a large number of sources. It's generated all the time. The data platform team might not necessarily know it's there because a lot of the times Goblin and other tools are built to be kind of data agnostic. We need to cycle through a large amount of data, and we need to do that without affecting other running jobs. And then we also, sometimes we need to do a quarantine record. So if we're not sure if this record belongs to a member, or we want to make sure we're not deleting too much, we want to make sure we have the ability to kind of soft delete data in a sense, and then hard delete it later. So you guys just heard the talk about all the Goblin pipelines and converters, so I'm going to skip this part. But logically, a purge job can be thought of as a fairly simple conversion task, or high level, it's very simple. You get in a record, you say, hey, you can have a list of all the members who want to delete their accounts. You say, hey, is this record pertinent for one of these members? If yes, delete it and return no rows back. If no, just return the row as is. Of course, it's not that easy once you implement this feature, but it's very straightforward from a kind of 10,000-foot view. And Anthony's going to talk a little bit more how we implement that in depth right after this. But I think one of the problems we've had is, and we have not figured out the solution, is that we have to go scan over all of our data. We have probably hundreds of petabytes. We scan hundreds of terabytes a day, and then kind of constantly read this file in, purge it, write the file back out, and we know it's going to cost a lot of heavy disk I/O. I don't think we've figured out a solution to this problem yet, so if anybody has one, we'd love to take advantage of it. So the next one is talk about how do you discover data and how do you deal with data governance. So LinkedIn, again, has bunch of different data systems all over the place. Databases at rest, we have things in Kafka, we have things on Hadoop, we have derived data stores. Many of these are open source, but there's data in a variety of places. And again, as a data scientist or even as a security person, you might want to know, hey, where are all the data sets on our system? Where do they live? Is this in Kafka? Is this in Hadoop? Is this in someplace else? How did it get created? How long has it been around? Things like that. And we built this tool called Warehouse for this. And Warehouse is open source. I think it was open sourced last year, I want to say. It was originally designed to be primarily for data scientists to help them discover data. We've been expanding that, and I'll talk about that. You can find our GitHub. So you can see a few screenshots, but essentially it lets you, we index a bunch of data sets, and we also provide metadata on top of those sets. So for example, Warehouse can go in and figure out what is the schema of this data set, what's some documentation associated with it. We talk about data lineage, so where does data set come from, who reads it to produce other data sets, things like that. Sorry, these screenshots are really small. But yeah, after you look at this from a security standpoint, there's other metadata that's very interesting from a data governance perspective. Which data sets have PII in them? Which data sets have member-to-member messaging data or other highly confidential pieces of data? Who can access them? When were they last accessed by who? Have they been purged in the last 90 days, or what other our requirements are? And the reason, and this is very interesting, and the reason it's a hard problem is with our data diversity, we have 20 different data systems, many different data formats, ORC, Avro, native database formats, could be other just custom formats. And we also want to understand more than just the schema. Understanding that you have 6 fields that are strings is not really enough. You have to understand the semantics. So Warehouse, kind of from a 10,000-foot view, has a bunch of different components. It can go out and scrape metadata from various sites. So it can go out and crawl HDFS and discover data sets. It can crawl your MySQL database and describe the table and pull out schema. It also will listen to event logs and things like that and pull in metrics about who's accessed this data set. This basically gets all stored in a centralized repository, and then with a combination of kind of human notation and machine learning process, it can decide this field probably means it's somebody's first name or it's somebody's last name, things like that. And then under the hood, it gets a little bit more complicated. But that's the idea, and we're kind of extending Warehouse more and more to power our metadata-driven features. I think a lot of these have been contributed back to open source. I think more will come, probably the next few months to come. But it's very powerful. I think the transition to metadata kind of driven data management has been, I think, a very interesting thing that we've been focusing a lot on in the past couple of quarters. And I'll hand it over to Anthony.
Thank you, Eric. Hey, everybody. My name is Anthony, and I work on the data management team at LinkedIn. The data management team consists of the Goblin team plus the Dolly team. I'll explain what Dolly is later on, but it's our data set access layer at LinkedIn. And I'm going to talk to you about the last part of the data paradox, which is how do you balance giving everyone access to the data versus protecting members' privacy. So, let's talk about some of the requirements. Of course, everybody wants access to all the data, especially analysts and data scientists. But, to protect members' privacy, it only needs to be shared on a business case basis. And by default, we don't want to make all of our data sets world readable. A lot of aggregations and metrics can be done on the obfuscated data as well without having to expose people's personal information directly. And finally, we give users a lot of privacy controls on the website. If they tell us that they don't want their data used for ads targeting, we need to respect that. So let's take a look at how we do that at LinkedIn. And just like all of you guys, we use a wide variety of frameworks here. Pig is probably the most popular framework at LinkedIn. Spark is probably the second most. It's growing in popularity. And of course, there are a lot of people using Kafka and Samza, which are both Apache projects that started at LinkedIn. And then you have SQL users using Hive and people using Scalding. So we have a lot of frameworks, and that's great for our engineers and data scientists. They can pick the favorite tool, they can get up and running very quickly. But it poses some challenges for us. every reader, every framework has their own custom Avro reader or ORC reader. And they're directly accessing HDFS and accessing specific file paths. So that makes it difficult for us to evolve our data format to something else. One option is to duplicate all of our data in multiple formats, but with dozens of petabytes of data, that's just not economical. But this direct dependency also poses some challenges for the analysts and the users themselves. As you guys know, business needs change and data models evolve. And tomorrow, we may introduce version 2 of some ad click event or some page view event. And then there are hundreds to thousands of scripts that you need to update to include these new data sets. And doing these migrations is a pain and is a big tax on a company at the scale of LinkedIn. So, to solve these problems, conceptually what we need is to build an abstraction layer on top of our data that users use. We need the ability to kind of manage each data set independently and evolve it independently, without requiring migrating thousands of scripts. And you can think of this sort of like in the online world, you have services that are deployed and upgraded independently of one another, and users just depend on their REST APIs. So at LinkedIn, the way we solve this is by building DALI, which is the team I work on. And DALI is LinkedIn's dataset access library. And its goal is to hide the underlying physical details like the HDFS path and what format it's in. And we want users to only think about what the logical dataset name they're reading is and what its schema is. So we've built a bunch of dataset readers here for accessing data, as well as tooling that lets users manage and evolve their datasets. So to dive a little bit deeper, the experience at LinkedIn working with dataset looks something like this. As a dataset owner, I will define a dataset using some SQL. And that can include SQL transformations. It could apply custom user-defined functions that do business logic. And I check this in to Git, so it's tracked and it's versioned. And we have internal tooling that publishes each version to our central jar repository called Artifactory. Once that happens, we have automated tooling that deploys this to our data catalog, which is the Hive metastore. So we have all of these tables and views registered in the Hive metastore. And these are the DALI datasets that users can now consume. And they can consume these datasets using any framework of their choice because we have built readers for Spark, for Pig, etc. All right, let's go back to the GDPR compliance. So, with DALI, now we have a way to be compliant. So let's take a data set like the member's profile data set. And using Warehouse, we can get metadata for these data sets. Warehouse lets you annotate these data sets with compliance information. So we can indicate that certain fields are personally identifiable information, such as the member's ID or their name. On the LinkedIn site, users specify their privacy settings. So, you can think of that as, I don't want my profile data used for a certain use case, like ads targeting, or don't share my email address with third parties. That could be another use case. And so for each of these, data set and use case combinations, we kind of store a bit, opt in or opt out for every user. So what you get is each one of these cells gets replaced with a bitmap. And we're storing a bunch of bitmaps for each cell in this table. And this is our member privacy settings. So you take that and you combine it with the metadata provided by Warehouse, and you can feed that into the DALI reader library. And the DALI reader library, which everyone uses to access data sets, can now also do compliance enforcement for us. Depending on the use case, it can do different transformations. Depending on whether an ads user is accessing the data, it can decide to filter out or obfuscate personally identifiable information. So let's take a deeper look at how that transformation library works. When a DALI, DALI reader is used to access a data set, we're executing, a SQL query. And a SQL query can be represented using an operator tree. You can think of it as scanning a data set, applying, a where clause, and then projecting some fields. And so we intercept this operator tree, and then we add our own compliance operator. And into this compliance operator, we feed our metadata. We can figure out which user is accessing this data set and which data set they're accessing. That's the query context. And we take in these privacy settings that the user has specified. And this operator can then filter out any personally identifiable information if there's no business use case for it. So now, putting it all together, how did we leverage Goblin in this pipeline? Well, being compliant is not just about filtering out data at read time. We're legally obligated to delete users' data when they close their accounts. So we actually have to permanently delete their data. So we take the same system, the same metadata, and we use the DALI reader, and we put that in a Goblin task that uses the DALI reader. We also keep track of which users have closed their accounts. And we also take this into consideration when doing our transformations. We filter out all records belonging to members that have closed their accounts. And in Goblin's case, it actually wants to purge the data. So what it gets out of the reader are only records belonging to active member accounts. Goblin then writes this data out to another location, which is the purged data. And the final step is to replace the original data with the purged data set. And with that, we're now compliant with GDPR, and we have solved the data paradox. And to recap, we did this using a combination of a warehouse for metadata, DALI as our data access layer, and Apache Goblin as a data management tool. Warehouse and Goblin are open source, so we'd like to invite everybody to contribute and collaborate on these. Thank you guys very much. This concludes the Big Data Meetup. Hope to see you guys next time. I'll give it back to Shashanka now.
Great talk, guys. Any questions so far? Eric, maybe you want to come back up?
Hi. How do you keep track of metadata from streaming frameworks? Like what streaming frameworks actually accessing it? And you talk about like a abstract reader, and there is a notion of compromising on the latency part also. So how do you balance it out?
Sure. So with streaming systems like Samza and Kafka, most of the data is stored in Kafka topics, and the retention on those data sets are generally, a few days to a week. And since the data is not retained for more than a week, we don't need to do any special filtering of those. However, the Dolly reader is general enough to be applied to those use cases. We're working on a Dolly reader for Samza as well, and that reader could also take in these metadata and privacy settings and do the same filtering in a nearline environment as well. All of this filtering only involves map-side operations, so they can easily be done in a streaming fashion as well.
A quick addition to that, since metadata was also asked about. A lot of Kafka topics are actually replicated to HDFS, and when Goblin ingests them, it actually produces what we call a lineage event, and that allows us to kind of get the mapping of a Kafka topic to a Hadoop data set. And so that allows us to acquire metadata only once on the upstream data set and then propagate it downstream. So you don't have to re-annotate a data set just because it's a copy of the original. Any other questions? Anyone else have war stories to share about data management or data integration? There's a lot of wine and champagne probably still left over. All right, thank you, everyone. And big thanks to all our speakers. We should probably get a quick picture with everyone. But so stick around. We're going to hang out for a little bit for more questions as well. And thank you.